In 1990, NASA sent Hubble Space Telescope to Earth's orbit. The main purpose of this telescope was to study cosmology, planetarium size, astronomy, and to verify various physics theories. One of the most important feature of the Hubble telescope was the Hubble Deep Field. Hubble Deep Field reveals that even in 1 square inches of sky have thousands of galaxies. Studying thousands of galaxies in deep field observation, including most distant galaxies, helped the scientists to know about the early condition of universe just after the Big Bang. Hubble observes that the distant galaxies are more irregular in shape than those which are nearer to us. Hubble observed different clusters of galaxies and together with computer stimulation come up with the cosmic wave structure. Using its powerful lenses, Hubble Space Telescope is able to determine a phenomenon called gravitational lensing. A gravitational lens is the distribution of matter such as a cluster of galaxies, black holes or neutron stars between a distant light source and observer that is capable of bending the light from the source as the light travels toward the observer. This effect is known as gravitational lensing, and the amount of bending is one of the predictions of Albert Einstein's general theory of relativity. The observer may then see a multiple distorted images of the same source, sometimes circular, called Einstein's ring. Hubble constant is an essential to know the age, size and curvature of the universe. Using the ground-based telescope, the Hubble constant was ranged between 500 to 70 km per second megaparsec. This gives the age of the Big Bang around 10 to 20 billion years. Using the Hubble Space Telescope, scientists refined this expansion rate and giving more accurate value of Hubble constant. This gives the age of the universe at 13.8 billion years. Thus, the Hubble is able to help scientists to verify the rate of expansion of the universe. Hubble telescope used to measure the distance of pulsating stars called Cepheid variables as standard candle within our Milky Way galaxy. Hubble studied the time period of the pulse and their composition and spectroscopy. The extragalactic distance in a series of techniques which we use today by the astronomers to determine the distance of cosmological bodies beyond our own galaxy, which are not easily obtained with traditional methods. Some procedures utilize properties of these objects such as type 1a supernova explosion. Other methods are based more on statistical and probabilities of things such as the entire galactic clusters. Type 1a supernova explosions are sometimes the best way to determine the extragalactic distance. This supernova explosion occurs when a binary white dwarf star begins to accelerate mass from its companion star. As the white dwarf gains matter, eventually it reaches its Chandrasekhar limit of 1.4 into the mass of the Sun. Because all the type 1a supernova explosion at the same amount of mass, their absolute magnitude are all the same. This makes them very useful as standard candles. Type 1a supernova have a standard blue and visual magnitude. Therefore, when observing a type 1a supernova, it is possible to determine what its peak magnitude was. Then its distance can be calculated. Scientists studied hundreds of supernovae in far distant galaxies, which are millions of light years from us. The supposed value of redshift in wavelength of their light, however, disagree with the findings. They appear to more fainter at higher redshift. More higher redshift, more fainter they are. Earlier, it was assumed constant rate of expansion of the universe, but Hubble space studies reveals that the expansion is actually accelerating. Today, scientists believe that this expansion is because of some mysterious dark energy. In the last 32 years of Hubble Space Telescope service, it reveals the secrets of black holes, quasars, pulsars, supernova, gamma ray burst, collision of black hole and neutron stars, center of galaxies, shape of black holes, early phase of universe, and more accurate studies of planetarium science and solar system. Hubble studies the birth and death of stars and various phases of stellar evolution. Hubble primarily used visible and ultraviolet part of spectrum of light, also a small portion of infrared spectrum from 0.8 to 2.5 microns. With its 2.5 meter diameter of mirror, Hubble able to look back 500 million years after the Big Bang. In order to look more nascent galaxies and first generation of star images, we need an instrument which are capable of using infrared spectrum of light with much bigger mirror. James Webb Telescope. The James Webb Telescope is the scientific successor to Hubble. Webb will primarily look at the universe in infrared. Hubble is in a very close orbit around the Earth, while the Webb will be 1.5 million kilometers away at a second Lagrange point. The diameter of the Webb mirror is 6.5 meter. This makes Webb capable of seeing the early phase after the Big Bang, which was not possible using Hubble. Webb can see even 50 million years after the Big Bang. After decades of development and many trials, the James Webb Telescope on 25th December 2022, it was launched with anticipation of beginning of a new era in astronomy. The program was perfectly executed, smoothly and successfully, and after 6 months it started sending images of far away gas clouds, nebulas, galaxies, clusters and cosmic structures with much more crisp image than human ever before. With its 6-meter aperture, James Webb is the largest telescope ever launched into space and from its vantage point a million miles from the Earth, free from Earth atmosphere. It is expected to deliver the best, most detailed view of the universe we have ever before. There is no doubt that it will revolutionize our understanding of the cosmos, just as its predecessor Hubble Space Telescope